Hi, and welcome to our first video in this series of videos on sequences and series from year 2 of the A-level course. And in this particular video, we're going to be looking at something called arithmetic sequences. But before we do, let's just kind of have a look at all the stuff that you've got to do within this topic. So there's a whole bunch of stuff in here, as you can see from the screen now. But essentially, what it is just understand we've got essentially two different types of sequences. And once you understand what's going on, it is just about primarily plugging numbers into formulae. So we've got arithmetic sequences, geometric sequences, and sums of those series and finding terms within those series as well. And then the last section, which will be our final video, looking at something called recursive definitions. But for now, let's just focus on the arithmetic sequences. So what we're going to be looking at in this video is knowing how to use the formula to find a particular term or a sum of a series, and then do a bit of problem solving with regard to arithmetic sequences. We'll get onto the geometric series stuff in a later video. Okay, so first things first, what is an arithmetic sequence? You'll be familiar with these. You'll have seen these a lot at GCSE, but you'll have been referred to them as linear sequences. If you did IGCSE, then you will have seen this in this way here. But for most of you, I suspect it'll be linear sequences, and it's basically a sequence like that where we've got a common difference. It's going up by the same amount each time. And what we're going to do is we're going to take a slightly different look at how we do this compared to how it's normally taught at GCSE. And we'll say, okay, we're going to take this sequence, and the initial value we're going to refer to as this thing here, A, and we're going to say that the difference is D. So for this sequence that we're looking at here, it's defined by those two parameters, A being 3 and D equals 4. Now, previously you'd have gone about finding nth term by looking at the difference and then working it from there. But I'm going to give you a slightly different structure. So here we go. In general, what we've got is a sequence with a bunch of terms, and I'm just going to call the first term, I'm going to call it A1, the second term is A2, A3, A4, all the way up to that one there, which is what you'd know as the nth term, which we're calling now AN. And so what you've got, the first term in our generalized sequence is A. The second term would be A plus D. So the first term, just add on one lot of the difference. And then A3, you just add on the difference again. So what we've got is A plus 2 lots of D, A plus 3 lots of D, and so on and so forth. And you'll notice the amount of the difference that we're adding on here, for example, if we're in the fourth term, so we're adding on 3 lots of the difference. Here with the third term, we're adding on 2 lots of the difference. So by the time we get to the nth term, we're adding on n minus 1 lots of the difference. Okay, so what that's telling us straight away is, so to find a specific term in the sequence, we've got that's the formula. The nth term is A plus n minus 1D. Okay, so there's our first formula to find any given term. That's the equivalent of the nth term that you'll have seen at GCSE. You might think, why are we bothering? It looks more confusing, but as you'll see later on, it does make life a whole lot more simpler when we get into how we have to deal with these things at A-level. Right, so moving on, what we need now is a similar formula, but this time for the sum of the terms in an arithmetic sequence. And when we talk about the sum of the terms, it's referred to as an arithmetic series. Slight change in terminology, but not one you need to worry too much about. And in order to do this, we're going to pull a bit of a sneaky trick. And it's a sneaky trick that is attributed to a German mathematician, a guy called Carl Friedrich Gauss, who was born in the late 18th century. Now, Gauss turned out to be one of the premier mathematicians of his time. He was like the granddaddy of maths around about the turn of the 18th century. But this story allegedly goes back to when Gauss was at school when he was 7 years old, and his teacher challenged him and the rest of the class just to add up all the numbers from 1 to 100. And Gauss absolutely nailed this in far faster than anybody else, and he did it by doing this. So he started off by saying, okay, let's take all the numbers, and I'm going to add them all up. And then when he got to 50, he said, okay, well, let's just keep going. And bear in mind, he was 7 at the time. And he went, let's just go back the other way and do it like this. So that would be 98 plus 99 plus 100. Because young Gauss noticed that what's going to happen here is when you add all these up, you end up with the same total, which is kind of handy. And then he went, well, how many lots of 101 have I got? Well, I've got 50 pairs, so I'm just going to go 50 times by 101, which is 5,050. Job done. What's next on your list of things to do? Please teach. So what we're going to do is pull exactly the same trick that Gauss pulled. Let's just get rid of that and have a little look. What we're going to do is start out by writing summation and in general terms. So we've got A plus D, and so on and so forth. So there's our first two terms, our last two terms. Now let's do what Gauss did and write them out again, but in reverse. There they go. And the same thing's going to happen that Gauss noticed we've got standard totals for our pairs, and that's going to happen for us as well. So let's just do some adding up. On the left-hand side here, we've got the total of the sum here, so total of the sum here. So we've got 2 times the total of the sum. So that's that bit. Then our total for each pair is going to be 2a plus n minus 1d. Just take a moment to have a look at that and make sure you're happy where that's coming from. And the same in the next term. And all the terms from there on in. So what we've now got to look at is Gauss's next thing would say, well, he had 50 terms. Well, how many have we got? Well, we've got n terms, which we kind of already knew because we've got going from a plus d, all the way up to our nth term, which is this one over here. Okay, so we've got n lots of that total, and then the last thing we need to do is do some dividing, bring the 2 over, and there you go, there's our formula. Again, looks a little bit unpleasant, but is actually genuinely really simple to use, as I'm going to show you now with a couple of quick examples. So, here we go. The first 4 terms of an arithmetic sequence are 2, 7, 12, 17. Find the 20th term and the sum of the first 20 terms. So all this is a case of dead forward, just dropping numbers into our 2 formulae. So we've got a equals 2, we've got d equals 5, we've got n equals 20. There's our formula. So we're going to go for a20, the 20th term, and that's going to equal 2 plus 20 minus 1 times by 5. And then sort all that out, and you end up with the 20th term being 97. What we're now going to do is the sum of the first 20 terms, so that's 2 plus 7 plus 12 plus 17 plus all the way up to plus 97. Again, same deal, just drop all the numbers in, there they go, and then just tidy up the right hand side, grab your calculator, and there you go, and they add up to 990. Now, that's all basic, straightforward stuff. Let's just now move on and look at how that might look within the context of an A-level question. You might get lucky, you might get a real straightforward one just as a 1 marker to get you going, but you're more likely to get something like this. So what we've got is we're given some information. We're told that we've got a sequence. We're told it's arithmetic. The 6th term is 3, and the sum of the first 2 terms is equal to the sum of the first 7 terms. And what we're being asked to do is find what the 10th term is. So all this is just a case of picking the information we need out of the question, put it into our formulas, and then seeing what we're going to get to play around with. And that's going to allow us to work out A and D. So let's pick out some information. There we go, there's our first piece of information. The 6th term is 3, so we know A6 equals 3. And let's now pick out our second piece of information, which comes from there. We're told the sum of the first 2 terms is equal to the sum of the first 7 terms. So we've got S2 equals S7. Okay, now let's just fill in some of that information with A's and D's, because that's what we're looking for. So over here, we know that there's our formula. So let's replace the n with a 6. And so we end up with 3 equals A plus 5D. Over on this side, let's use our summation formula. There it is. And so let's create a formula for S2, which is that one. Create the formula for S7, which is that one. The only thing we know at the moment is n. And do a bit of tidying up with both of those. And that one on the left just all ties up to 2a plus d, because a whole bunch of 2's do a bit of cancelling out over here. And then on this side, we end up with 7a plus 21d. Okay, so hopefully you can see now we're starting to create a couple of simultaneous equations. We've just got a little bit more work, I think, to do with the one on that's down here from our summations. So let's tidy it up. There it is. And now bring it over there and do a little bit of simultaneous equation work. Obviously, more than one way of doing this. This is just the way I've chosen to do it. Quick subtraction eliminates the a's, and we end up with d equals 3. And obviously, once we've got d equals 3, we just go back to either of those equations, plug the value of d equals 3 back into there, and that leaves us with a equals minus 12. We've now got the values of a and d that we need. And so what we're going to do is just now answer the question. It says find the value of the 10th term, which is nice and straightforward now. So there you go, a10 equals minus 12 plus, there's my n minus 1, minus 12 plus 9 times 3. So the value of the first 10 terms was 15. Right, so that's one kind of question you might get, but more than often than not you get something that is contextual. So I've come up with a slightly convoluted but contextual example that this kind of thing you might come across on the A level. So we've got two people, Penny and Rajesh, on a fitness program on indoor rowers. So Penny decides to row 100 meters in the first week and then increases the distance each week by d meters. Rajesh does something similar, but he starts off by rowing a little bit further, 1500 meters, and then increases it each week by 150 meters more than Penny. And we're given a fact that says in the nth week, Rajesh rowed twice the distance that Penny rowed. And the first job is to show that. So we've got to show that our distance is given by this rather unpleasant looking formula here. Okay, so let's go for it. It looks nasty, but again, as with all these things, I'm never going to try and say, well, I know exactly where I'm going right from the start. What I'm going to do is just start by breaking down the question, putting in the things that I know, and then seeing where I end up. So let's start off with Penny. So in the first week, so we've got A equals 1,000, and we've got the increase is D each week, and we're doing it for capital N weeks. So we get that. For Rajesh, his initial distance was 1,500. There it is. And the increase is going to be pennies, which is D, plus an extra 150. So what we end up with for Rajesh is that one. And what we've got is that fact. So Rajesh, in the nth week, Rajesh rowed twice the distance that Penny rowed. So the actual distance he rowed, so I'm going to go AR, that's the amount that Rajesh rowed, is twice the amount that Penny rowed in that particular week. So what we can do is just bash those two things together. There it is. So here's the amount that Rajesh rowed is twice the amount that Penny rowed. And now what we're doing is looking to work towards just making D the subject of that formula. First job, do some multiplying out of brackets. There we go. Next job is try and get all our D's all over one side and do a bit of rearranging. So it does tidy up quite nicely. Factorise on the left. And then your final step is do the divide, and you can see the result we wanted drops out quite nicely. Right, so that's the first part of that question. We included the second part, which says, hence or otherwise, find the week in which Penny first rowed 2,000 metres. So what we need is, there's our formula for Penny. So for the distances she rowed in any given week. And we know that in the nth week, she rowed 2,000 metres, and we now know D, algebraically, is this thing here. So by subbing that in, that gives us an equation just in terms of N for us to solve. So again, it's just now becomes a job of just kind of rearranging algebraically, tidying up and seeing where we end up. So I've moved the 1,000 over to the other side, and then taken the 1 minus N across there as well. Multiply out some brackets. We've got a quadratic on this side, so you can see this thing is turning into a quadratic equation. If it's a quadratic, let's get it equal to 0. There it goes. And now we've got to solve a quadratic, and at this point, hopefully you're familiar with either typing a quadratic formula into a calculator or just putting it into your equation solver on your calculators. Whichever way you do it, we end up with N equals 11. And so what we've got is, it tells us that Penny rowed 2,000 metres for the first time in the 11th week. Job done. That's all we need on arithmetic series. It's just a case of initially the formulas, then how that would look in terms of questions on your exam, in terms of contextual questions and other kinds of problem solving questions. Next video we'll have a look at doing exactly the same thing but with something called geometric series.